Hello, and I want to welcome you back. This is the second half of Chapter 7, where we will be looking at graphing two equations and seeing if they intersect, and if they do, the one intersection point will be an answer to the linear equations, the systems. If there is no solution, meaning the lines are right beside each other having parallel slope, they'll have no solution because they'll never touch. And if we only wind up graphing one line, that means the lines are on top of each other, meaning that we have infinitely many solutions to the linear equations. Alright, so let's get started with problem set 2, graph the system of linear equations. Okay, you can use any way you know how to use a graph to graph these equations. And what I like to do is put them in the form y equals mx plus b, where m is the slope and b is the y-intercept, where we graph b first, then we use the slope to plot the points. So if we do that first, we want to get x on the other side. If we look at this first equation, x plus 3y equals 4. To start getting it in this form, we want to subtract x on both sides. So we have 3x equals, let's bring that negative x, and it's going to be a positive 4. Let's bring it down 2. Let's divide 3 on both sides, and that's going to leave us with y equals a negative 1/3 x plus 4 over 3. Okay, and then if we want to look at the second equation of 2x plus 4y equals 6, let's subtract 2x on both sides. We have 4y equals negative 2x plus 6. Divide 4 on both sides to get y by itself, and we're going to have y equals negative 1/2 x plus 3 over 2. Now when it comes to graphing, I'm going to graph the blue first. So we start by graphing the b, which in this point will look like 0, 4 over 3, which looks like that's going to be about a little less than 2, but above 1. So if we plot it right there, and then we use our slope of go down 1 to the right 3. We now have 2 points on the 4-quadrant plane to graph. So let's do that. Do the best we can to graph both of those. I think that's going to be as best as I can do with what I have. Okay, and if we graph the second one, it's going to be about 1.5, which will be, that will be right here. Let me go back to my pen. If we graph the second one here, I believe we'll graph about right here, and we'll use our down 1 to the right 2. And now if we use our graphing tool, let's see what we can do. Actually, I think it's going to turn out really nice. So it may not have been the best to graph since we had fractions for the y-intercept, but if you look, there is going to be an intersection point somewhere around in there, and so we have one solution. And if we are able to graph, we could actually tell what that solution will be. Now if we look at the second example, let's do our same process of putting it in y equals mx plus b. Okay, so for this first one, x plus y equals 3. Start off by subtracting x on both sides. So I'll have y equals negative x plus 3. Let's go ahead and graph this. So we'll graph our y-intercept, of 3. We'll go down 1 to the right 1. Graph that second point. And we'll do the same thing if we want to continue that pattern. Okay, so now we have a set of points we can work with. Let's graph these. Okay, so that turned out pretty nicely. Let's work with the second equation. 2x plus 2y equals negative 4. Start off by subtracting 2x on both sides. We have 2y equals negative x plus 4. Now to get y by itself, we want to divide by 2 on both sides. So we get y equals negative x plus 2. Okay, and if we try to graph this, let's graph our y-intercept of 2. So there's our y-intercept. We go down 1 to the right 1, up 1 to the right 1. And it may be hard to tell because of our graph, but these are going to be parallel to each other. Because the slopes are the same. Okay. And actually, for this purpose, there was a mistake I need to mention. If you look right here, that should have been a negative 4, but I actually wrote a positive 4, it looks like, or I didn't carry it through. So actually the equation should be y equals negative x minus 2. But if you notice, since the slopes are the same either way, that the y-intercept would not matter, that you're going to have parallel any way you do this problem. Regardless of what the y-intercept is, if the slopes are the same, we're going to have the same. If the y-intercepts are different but the slopes are the same, we're going to have two parallel lines. Okay, and finally, let's take this last example. Excuse me. Let's take this last example and put it in y equals mx plus b form and then graph. So we have 2x plus y equals 3. And let's start off by subtracting 2x on both sides. So we have y equals a negative 2x plus 3. So if we graph this, we want to start off by graphing positive 3 and go down 2 into the right one. So we have that line graphed. Now let's go through and look at the next one. 4x plus 2y equals 6. So let's subtract 4x on both sides. So we have 2y equals negative 4x plus 6. Let's get rid of that 2 by the y by dividing it on both sides. And when we get the final equation, we have y equals negative 2 plus 3. And if you look, that's the exact same line that we just graphed. The reason we got this is because we have infinitely many solutions, meaning one line was graphed. And if you look at the original equations, 2x plus y equals 3. If you were just to take this whole equation and multiply it by 2, you would get the bottom equation. 2 times 2x equals 4x. 2 times y is 2y. And finally, 2 times 3 is 6. So it's just a multiple of another equation is why you only have one line.